So in this video, are now discussing all about rolling bodies in pure contact. So before we start the discussion about the pure contact in two bodies, so let me define first what is pure rolling, and we have we have discussing first all about rotational different kinds of rotational variables, uh, and we have to derive the linear velocity in relation with angular velocities. So, so the pure rolling. So the pure rolling is a combination of pure rotation and translation. So obviously, it cannot be termed as pure rotation as far as the actual motion is concerned. Okay. So for the rotational variables, so we have to define what is a angular position. So the angle of the reference line relative to the positive direction of the x-axis. So as we observe this graph from this Cartesian plane, we have this y-axis and x-axis, and this rotational axis that is passing through the origin. So we have this linear reference line. So if we rotate this rotation axis, so we can get or we can get the position of this reference line. So by measuring with the positive x-axis. So if we get the position or the angle of this reference line, so makuha pod nato ang iyang distance or kanang sa arc length of this reference line. So for the equation of this, para makuha nato ang iyahang arc length, so we have theta is equals to arc length over the radius, or equals to s over r. So as we observe this equation, so the arc length is dependent by the angle. So as we increase the angle, so mo increase po ang ato ang arc length, or in mathematical speaking, so your arc length is directly proportional to your angle. Okay. And then the unit of your theta or your angle is in terms of radian. So for the angular displacement, we have this definition. So angular displacement is a body's rotation about its axis, changing the angular position from theta 1 to theta 2. So para ma-clear na to, masabtan, so uh, we have this graph. So by this Cartesian plane, we have y and x axis, and then we have rotation axis that is perpendicular to y and x axis, or passing through the point of origin. So at initial time, or what we call time 1, so we have this position, or what we call the theta 1. As time goes by, So if we move this rotation axis, so maka-create siya og displacement and atong tawgon siya og at time 2. So in this angle or the position of this reference line is atong tawgon og theta 2 or angle 2. So as we observe this graph, so makuha na to ang makuha na to ang value sa displacement or angular displacement. Okay? So as we observe this line, so saan na to pagkuha iyang uh, change of angle. So by the difference of these two angles, we have theta 2 minus theta 1. So change of theta is equal to theta 2 minus theta 1. So however, exploit the fact that the bodies in rolling is actually rotating at any given instant, not over a period of time, but for an instant. Okay? So, ang pagkuha sa itong angular velocity or the linear velocity is in terms of instantaneous or not a period of over a period of time. But if we know or the average angular velocity, so uh, we must consider the period of time. So we have this formula. We have average angular velocity is equals to the angular displacement with respect to the change of time. So theta time 2 minus the time 1. For the instantaneous angular velocity, we have this. So dapat mogamit ta og limit no nga equation. So from the word instant, so atong kwaon ang uh, iyahang angular velocity with a specific of time. So ato ang time day ani, so kaniti ni siya, so ato i-approximate into 0 or this equation can rewrite into form d theta over or with respect to differential time. In relation between linear and angular variables, so we have to derive this. So let us assume that this point P is traveled by this distance circle, ano siya? And then the position of your magnitude velocity of this at which a point moves. So V is a tangent to the circle in which a point moves. So since all points within a rigid body have the same angular speed or omega, points located at greater distance with respect to the rotational axis have greater linear or tangential speed. So as we increase this radius, so magka-increase pod ang uh, ato ang sani siya tangential speed or this at point P magka-increase ang iyahang movement kung i-increase pod nato ang iyahang radius. So for the position as we discussed earlier that S is equals to theta r or theta always in radians. So for the speed we have this equation. So if we take derivative of this position, so we can have this equation. So we have ds over dt is equals to r d theta over dt, or with respect their differential time, where your d is over dt can uh, can rewrite into form velocity or v, in your d theta over dt can rewrite into form omega. So if omega is constant and b is constant, so each point within the body undergoes uniform circular motion, where your omega in terms of unit is in radian per second. Let us have the rolling bodies. So for the external cylinder, we have this figure. So the bigger circle, we call it a cylinder 1. And your smaller circle, we call it a cylinder 2. So, so the distance between these two centers is atong tawagon og center distance, or equals to C, where the equation is C is equals to R1 plus R2, or the sum up of the radius of these two cylinder. So R1 plus R2, or in terms of diameter, we have C is equals to diameter 1 plus diameter 2 over 2. So in order without slippage at a point of contact, so this point of the cylinder, the linear velocity of cylinder 1 must be equal to the linear velocity of the cylinder 2. So, say pasabot aning slippage. So, dapat uh, dapat i-equal na to ang kaning velocity kaning duha ka cylinder, para dili mo move or consistent gihapon ang iyahang point point of contact diri. So we know that velocity is equals to omega r, where v is equals to omega r can rewrite into form v is equals to 2 pi rn, or in terms of revolution per minute. So we can rewrite in this form v equals to 2 pi rn, where your diameter is equivalent to 2r, or twice the radius. So r is equals to d over 2. So if we substitute this radius to this equation, so makancel out ang 2. So 2. So ang may bilhin na lang is v is equals to pi dn. So as we explained earlier, that your v1 is equals to v2. So we can rewrite this equation to this form: pi d1 n1 is equals to pi d2 n2, where your v is your linear velocity and d is your diameter of the cylinder and n is your rotational speed of the cylinder in terms of revolution per minute. So for the internal cylinder, we have this figure. So for the bigger circle, so atong tawagon og cylinder 1, and for the smaller is your cylinder 2. So if you locate this center, so ingani ni may tabo sila center no, duha ka center. So as we observe this figure, that your center distance becomes C is equals to R1 minus R2, or difference lang duha sa kaning cylinder, reduce, or the measurement of this reduce. So to prevent a slippage, so dapat consistent gyapon natong point of contact diri sa duha ka cylinder. So we must be equal their linear velocity. So we have B1 is equals to B2, or equivalent to pi D1 N1 is equals to pi D2 N2, where B is equals to linear velocity and D is equals to diameter of the cylinder, and N is your rotational speed of the cylinder. So the unit for this is in terms of revolution per minute. So for the rolling cones, we have external contact. So it is similar for the internal and external na cylinder. So we must be equal sa the velocity or linear velocity in order to prevent slippage. So sa diri nga point, sa diri nga contact. Ang nakalayan lang is naka-create siya og angle. Eh. So for the alpha, so the angle alpha is the angle of your uh, bigger bigger shaft or bigger cone. In your beta is your angle of smaller cone. In your theta is the angle of between these two shafts. So this bigger cone, we call it your cone 1 or cone 2 or your radius 2. In smaller cone, we have this cone 1 or radius 1. And we have rotational speed for these two shafts, N2 and N1. So since V1 is equals to V2, so if we go back to trigonometric function, wait. So we have this formula. So 2 pi R1 N1 is equals to 2 pi R2 N2. So as we observe this equation, so makancel out ang 2 pi. So ang mabibili na lang is your R1 N1 is equals to R2 N2. So if we go back to the trigonometric function, so your sine beta, so assume this triangle, so we can create uh, sine function. No? So we have sine beta is equals to R1 over H, where R1 is your opposite, in your H, this triangle is your hypotenuse side. And for the sine alpha, we have this R2 over H, where your R2 is your opposite side. So sa kaninga triangle, and your H is your hypotenuse side. And your alpha, we can rewrite into form uh, beta minus beta. So this sine beta, this R1, so if we substitute this, so the equation becomes H sine beta N1 is equals to H for the R2, H sine alpha N2. So we can cancel out the H. So may bilin lang is sine beta N1 is equals to sine alpha N2. And your alpha, we can rewrite into form theta minus beta. So, so from this angle, so we have this theta, and then minus na nato sa beta. So ang result is your alpha. So sine theta minus beta. From the trigonometric identities where sine theta minus beta is equals to sine theta cosine beta minus cosine theta sine beta. So if we substitute these identities, so we can have this equation. Sine beta n1 is equals to sine theta cosine beta minus cosine theta sine beta times n2. So if we divide both side of n1, and we have to this cosine theta sine beta times n2 over n1 is we have to move into another other equation. So mangyani na iyahang equation. We have sine beta over cosine beta is equals to sine theta minus cosine theta times sine beta over cosine beta times n2 over n1. Or your sine beta over cosine beta is equivalent to tan beta. Or this equation we can rewrite into form tan beta plus cosine theta times tan beta times n2 over n1 is equals to sine theta times n2 over n1. So we know that this tan beta is common factor. So pwede na ito pagawas sa kaninga equation. So tan beta times 1 plus cosine theta times n2 over n1 is equals to sine theta times n2 over n1. And if we divide both sides, this 1 plus cosine theta n2 over n1, so the equation becomes sine theta n2 over n1 all over the 1 plus cosine theta into over n1. So, we know, kung ato ni pagawas ang into over n1, so, mahinganan niya ang form sa imong equation. So, sine theta n2 over n1 all over 1 over into over n1 plus cosine theta times into over n1. So, dapat divide ta og into over n1 sa kaninga 1 nga variables kay para if we kung ato times, so mabalik siya sa into form nga 1. So as we observe this equation, so makancel out ang into over n1. So for the final equation, we have this. So tan beta is equals to sine theta all over n1 over n2 plus cosine theta. So if we use your angle alpha, so we can reverse sa kanira nga kaninga rotational speed. So we have this equation. Tan alpha is equals to sine theta over n2 over n1 plus cosine theta. So kung mo use ta sa angle alpha. So where theta is the angle of between shock, beta angle of the small cone, alpha is your angle of the large cone, n1 is your rotational speed of the small cone, and n2 is your rotational speed of the large cone. So for the internal contact, so we have this figure. We have alpha. So this alpha is your angle of the large cone, and your beta is your angle of the smaller cone, and theta is your angle between these two shafts. So R1 for the larger cone, and R2 is for the smaller cone. So, in order to prevent a slippage or para consistent gihapon ang ato ang contact diri while ah, nag-move sila, na movement nga nahitabo. So, dapat i-equal nato ang velocity nilang duha. So, since B1 is equals to B2, so we have this equation 2 pi R1 N1 is equals to 2 pi R2 N2. So, we can cancel out the 2 pi. So, may bilin lang is R1 N1 is equals to R2 N2. So, we know that sa ato ang trigonometric function that sine beta is equals to R1 over H. So, this R1 over H. Asa na yun? So, kani from here. So, maka-create ta og triangle diya. Then, for your sine theta plus beta is equals to R2 over H. Theta plus beta. So, if we substitute this R1, this equation of trigonometric function, so we have this equation. So, H sine beta n1 is equals to H sine theta plus beta times n2. So, we can cancel out the H or variable H. So, from the trigonometric identities where sine theta plus beta is equals to sine theta cosine beta plus cosine theta sine beta. So, we have this equation. So, sine beta n1 is equals to sine theta cosine beta plus cosine theta sine beta times n2. So, if we divide n1 and cosine beta, so may nga ni iyahang form sa iyang equation. So, we have tan beta, so kani, divide into over n1. So, tan beta is equals to sine theta na lang plus cosine theta times tan beta into over n1. So, if we move this equation to other equation, so we have this. So, tan beta minus cosine theta tan beta times into over n1 is equals to sine theta into over n1. And we know that this tan beta is your common factor. So, atong ipagawas, so tan beta times 1 minus cosine theta times into over n1 is equals to sine theta into over n1. So, if we divide 1 minus cosine theta into over n1, so ang equation becomes sine theta into over n1 all over 1 minus cosine theta into over n1. So, para makancel out ning into over n1, so ato ni ipagawas ang kaning into over n1 sa denominator nato. So, we have sine theta into over n1 all over 1 over n2 over n1 minus cosine theta times into over n1. So, makancel out ang n2 over n1. So, for the final equation, we have this equation. So, tan beta is equals to sine theta over all over n1 over n2 minus cosine theta. So, that's all for now, and thank you for listening and have a good day.